In this last slide deck for this unit, I'm just going to talk briefly about GCC, which is used for compiling from source. We just talked about compiling from source, so why am I talking about it again? This is more specific about the options available in the compiler and a little bit more about the compiler itself. The thing about compiling from source is that in the previous slide deck, I talked about using the doc, using /configure and then using make and then make install. And when you run those commands, you never actually run the compiler yourself. It's being done for you, right, through these utilities. So you're abstracted from the compiler a little bit. So here we're just going to talk about the compiler a little bit, just so you have a little bit of background on the compiler. So the GNUC compiler, or its GCC is the command. There's also a version of it called G++, which is used for compiling C++ code. A lot of the things that we do in Linux are in C, right? C is a very old language, but it's still very much relevant. Linux itself is written in C, so a lot of the utilities and applications that we run in Linux are also written in C, but a lot of things are also written in C++. Of course, there are other programming languages like PHP or Perl, Python, Java, .NET, and C# and things like that. But and of course, all of those, there are applications that can run in Linux, and all of them have their own either interpreters or compilers. So you'll certainly have to deal with some of those as well. But commonly for open source, we're usually talking about either GCC or G++. Most compilers, including GCC, are going to have some pre-processing, the lexical analysis, which breaks the program into components, and then syntactic parsing, then semantic analysis, and then finally optimization. So the GCC has these features. We'll just talk briefly about these. So when you run the GCC command, there are some options that you can pass into it. Your book talks about these in more detail. During the compilation, if it finds an error, it's going to stop and pass all the errors to the user. There could be lexical errors that you have to fix, syntactical errors, semantic errors. Some of them will be warnings, some of them will be errors. If it's a warning, theoretically the compiler can continue, but these are options that you can pass to the compiler. You can say ignore the warnings, just show them to me, but go ahead and compile anyway, right? And it'll just keep moving forward. There are some errors that it cannot compile. Syntax errors, for example. Most common thing you'll see is syntax errors if you write your own code, and the compiler will not be able to continue if you have a syntax error rather. So your book talks a little bit about what these some of these errors are. Again, this is not a programming class, so I didn't want to get into too much detail. We already covered programming in some detail when we talked about bash scripting, right? Of course, in C, it's very similar, same types of control structures, loops, and, conditionals and things like that, and assignment statements. So very similar. C, obviously, there's a lot more you have to be aware of with memory management and libraries and things like that, which you would certainly learn about if you take a programming class. But your book does talk a little bit about some of the things that you might encounter when you're when you're taking source code and trying to compile it yourself with GCC. As I said before, it's not common for administrators to do this, but if you're writing your own application, certainly you will do this, and this is something you'll learn about in a programming class if you're learning how to write applications in C or C++ or any other programming language. So in languages like C, the code can be broken down into functions. We learned about this with Bash, right? So it's not all that different from Bash. So it's just, it breaks the program down into parts that can be run independently, within the application. We kind of looked at how to do this when we did some of our exercises with Bash. So linking is this concept that you can use libraries, right? So libraries are other people's code that you're going to use within your own code. For example, if you wanted to add or subtract numbers, someone's already written the code to do that. You don't have to write the basic instructions on how to do basic arithmetic operations. Someone's already done that, and it gets even more complicated, right? String functions, for example. We learned about string functions in bash scripting. We learned about using regex and the set and awk commands and things like that. If you think of those things as libraries, you don't have to understand how those utilities and applications work, but you have to understand how to use them. And that's kind of how libraries work in programming. Libraries provide you some functionality. You don't really have to know how it works, but you have to know how to work it, right? With the documentation. Now, when you have those libraries, if you have the source code for those libraries, they could be separate libraries, or you can compile them into your application. Now, what's fundamentally the difference? If the developer of those libraries maintains it independent of you, it's a good idea to link to it, right? To not compile it into your software, because if they make changes to it that improve it or patch known vulnerabilities and things like that, then you can leave that up to them, right? And it can stay separate. So generally, using DLLs is considered best practice in many cases, but that does create a dependency for the application. So this is just an example of using the GCC command. You basically type the command, some options, and then the name of the file that you're trying to compile. Here are some conventions for the files that are used. .c is for C source code. .cpp is for C++. The file extension is .m, it's Objective-C. .h is for a header file. .o is for an object that's already compiled, like a library, for example. .f for Fortran. .abs for ADA code. .s for assembly code, right? These are just some of the and you don't have to use these extensions, it's just the conventions that are used. These are some examples of running the GCC command with some options from your textbook. Dash capital WALL means with all, right? So with all warnings. And there's a list in your textbook of some of the different options available to you when you're running the GCC command, just like all the other commands we've learned about in this course. And finally, software documentation. If you are writing your own software or making changes to software that you're compiling from source, that you're at this level where you're using the GCC to compile it, you probably need to document what you've done and how it works, because otherwise someone's going to have to reverse engineer it from your source code later on. So it's always a good idea to make sure we have copious documentation.